See, in this question what they have said, there is a main transformer having turn ratio. Turn ratio means this one is n1 and this one is n2, right? So now we know the value of n1 is 44 and n2 is 1, is connected to a 220 main supply, means v1 is given, that is 220 volt. So as you know that our rectifier is connected with the secondary winding of the transformer now, not with the primary winding. So we have to calculate the for the half wave rectifier they said, so we have to calculate the value of v2 because v2 is connected with the diode only. So as you know the formula, that is n2 by n1 is equal to v2 by v1. n2 is 1 by 44, v2 is, we need to calculate, v1 is 220. So v2 would be how much? 220 divided by 44, that would be equal to 5 volt. Okay, so from here we'll get the value of v2, that is 5 volt. Now they said if the secondary output is applied to a half wave rectifier, determine the peak voltage. Peak voltage is the maximum voltage, right? This one, if they have given the vrms, so they have given the v1 rms, right? You know na, rms is the root mean square, and so we'll get the v2 rms only. Now they are asking for the peak voltage. Peak voltage is the maximum voltage, that is v max. So they are asking for the v2 max. So as you know the formula, that is vrms is equal to v max by root 2. Okay, this is the relation, but they have said for the half wave rectifier, right? That they said now half wave rectifier. For half wave rectifier the relation is vmax by 2. For the full wave it is vmax by root 2. For the half wave it is vmax by vmax by 2. Now the we know the value of this one v2 rms, then we'll get the value of v2 max, right? Got it?